So we're going to look today at some more kinematics, and we've seen kinematics earlier on when we've seen UVAT's equations, equations of motion, and this is slightly different though, because this time, rather than having a constant acceleration, which UVAT's is based on, our acceleration is written as a function of time, as is our displacement and our velocity. These things are written in terms of t. And when we have displacement, velocity, and acceleration written in terms of t, to find the link between each other, then we have to either differentiate or integrate. And if we start with displacement and we differentiate displacement with respect to time, ds by dt, we get velocity. And if we take velocity and differentiate with respect to time, we get acceleration. So s, then v, and then a as we differentiate. S, ds by dt, d squared s by dt squared. On the other hand, if we start with acceleration and we want to find our velocity, then we're going to integrate acceleration with respect to time. And that'll give us our velocity. But also, because we're integrating, we're going to get a constant of integration here. And this is very, very important that we remember this when we're integrating. If we have velocity and we integrate it with respect to time, then we end up going back to displacement. But again, when we integrate, we get a constant of integration there. I think sometimes remembering which way round it is, I think if you hark back to the s equals ut plus a half at squared, the UVAT's equations, not quite completely true, but if you look at this and differentiate that, then when you differentiate a ds by dt with respect to t, well, ut with respect to t is it differentiates to give u. A half at squared with respect to t gives you at, and we know that v equals u plus at. And if we then differentiate this again, so dv by dt, we'll use a constant, so it differentiates to give nothing. At just differentiates to give a, acceleration. So sometimes that can be a wee hint if you're not quite sure about which way is which. We start with displacement and we differentiate to get velocity and acceleration, or we start with acceleration and we integrate to get velocity or displacement. So we've got a couple of wee examples here. A particle P moves in a straight line such its displacement from a fixed point is given by x equals 2 plus 3t minus 2t cubed. And here you can see the displacement is in terms of t. So it's not constant acceleration. It must be this s, v, and a, and differentiating and integrating. So first of all, find the distance of P from O when t equals 0. Well, rather than x, I'm just going to use s. So s is equal to 2 plus 3t minus 2t cubed. And when t equals 0, s is equal to 2 plus 0 minus 0. So it's 2 meters. Oops, I don't know why I underlined that, but I'll do. So 2 meters is the displacement. It's also the distance here. The distance of P from O when t is 2. So same sort of thing. We have s is equal to 2 plus 3t minus 2t cubed. So when t equals 2, we get that this is 2 plus 2 times 3 is 6, minus 2 cubed is 8, minus 16 then, and that is minus 8 meters. But that's the displacement, so make sure that we give the distance as 8 meters. Okay, because in the question there, it doesn't ask for the displacement, it asks for the distance. So make sure you give your answer as a positive number. Now, part C, the velocity of P when t equals 0. Okay, let's go over here. Well, again, we know s is equal to 2 plus 3t minus 2t cubed. If I want the velocity, I'm going to differentiate s with respect to time. Differentiate 2, we get 0. Differentiate 3t, we get 3. And differentiate 2t cubed, we get minus 6t squared. Now when t equals 0, the velocity is 3 minus 0, which is 3 meters per second. And finally, part D, the acceleration. Well, again, we now know velocity is 3 minus 6t squared. So the acceleration is we take the velocity and differentiate it with respect to time, which gives us minus 12t. And when t equals 1, the acceleration then is minus 12 meters per second squared. And we'll leave it like that. We're not asked for the magnitude of it, so we just leave it as minus 12.